are an Indiana company. We're a manufacturer, actually. We manufacture complete teaching systems, mostly in the technical areas, technical and trades. Most of our customers are community and technical colleges. We do have some rather large manufacturers, those manufacturers that are large enough to support industrial training centers and the like, so the GMs, Fords, Caterpillars, and those folks, we do a lot of work with them. We are partnering really with Ivy Tech and the corporate college system, and I want to make that point first. I'm here as a support to Randy and Kim because what we want to do is have you benefit from their expertise and the things they can bring closer to you than what we can supply. Also, that you don't have to buy everything from Amatrol to do training, and particularly the hands-on part, which is expensive, but you can work with your local community college with Ivy Tech and get the benefit of their assessing, their advice and consultation, and once you've done some content work, their laboratories and their hands-on hardware. So I think it's a win-win kind of situation. This screen that you see right now is, as Randy was mentioning, from the Basic Electricity online learning resource. One of the things I want to point out, this is exactly the same as the table of contents would be in the book. And it's actually a little more than a workbook. It actually has all the content, all the cognitive knowledge you would need. In fact, if you look here, here's one of our first skills: use an AC tester to check a wall outlet. Or let's go down and connect and operate a power supply. Now we're at the very, very beginning of basic electricity here. We're assuming the person coming in the door knows nothing about electricity. It might be the mechanical guy who never had a course in electricity, but now he has to also do electrical things on the shop floor. And notice that these skills, if you look at the skills, those skills are the kinds of things people messing with electricity, that's a technical term, do in the workplace. And what we're trying to do is build on this knowledge and body of skills. Another thing I want you to notice is in manual input devices now, we're going to talk about a manual switch, normally open, normally closed, 3 types of switches, and their advantages for different things, and schematics and all of that. What we do is we identify a skill, and we only give the cognitive information, the knowledge that you need to perform this skill. This methodology has proven very successful for us and for our customers. Basically, we're not saying you have to read 35 pages on electron theory, and then you're going to go into the lab and put a circuit together. What are you going to do there? You're going to lose a whole bunch of stuff that you didn't need yet anyway. We may get to that electron theory, we may get to resistance when it's appropriate, but if you're just going to hook up a circuit, you don't need all that. You just need to know what the components are and so forth. So that's the way we approach all of our systems, and the content is developed based on what industry tells us. All of these skills came from task analyses from industrial applications. So I'm going to show you one of my favorite little interactions here. This is describe a normally open, normally closed contacts system. I don't have sound. Where'd the sound go? Did I forget to push a button? Oh, it's up here over there. Nope. Nope. On the computer? Oh, okay. Sounds like we got sound now. We got this 60-cycle hum.
Switches use 2 types of contacts.
Right.
Normally open, or NO, and normally closed, or NC. The schematic symbol for each type is shown here.
And one of the things you'll see here is we give a little clue that these are interactive.
These contacts are open until acted upon by the operator. Current flow is prevented. Activating the operator will close the switch's contacts, which will allow current to flow.
And if I click down here,
these contacts are closed until acted upon by the operator. Current is able to flow. Activating the operator,
I took my mouse away, so it went away. I'm going to turn the sound off because that's something that any of the users can do. For those who read, they can read faster than that narration was going, and it gives them the opportunity to move through the content faster. Notice, though, we're talking about switches here. We're given the schematic symbol all the way around. We want the learner to understand what they're looking at when they see these symbols on a drawing. This is interactive again. Anytime you see this little thing, it means it's interactive, and basically it tells you, oh, all right, on a normally open switch, when I push the button, that activates, and I can even see now, oh, okay, current can actually flow through because these things are all connected to each other. This light's already on. When I push that switch, it goes off. And you can begin to see, well, there might be some applications that have to do with those kinds of switches. And we get into that as time goes on. One of the things I want to move forward to, by the way, you notice I can navigate anywhere I want to go. I'm going to go right to one of the skills. We've designed the software so you can go anywhere you want, like a book. You don't have to, you've been through program learning, you know, you get into these loops where if you don't complete this and get it right, you can't go on to the next step, and then you complete that and get it. If you want to go in there and go to the third step, you got to go through a bunch of stuff to get there, or you can't get out when you want to. We're working with adult learners. We know you want to come and go and get to where you want to and navigate wherever you need to be when you want to be there. So this is going to be a skill, and I'll just play a little bit of the skill, at least show you what it's going to say. In this procedure, you're going to hook up 3 different switches, and we have a couple of options. This is the piece of hardware that Randy has in his lab. So when you come to do the hands-on work, you've got this list of skill performances, and by the way, we don't leave out anything. If you've never seen a switch or a power supply or anything before, you don't have to worry. Teachers can come in here and learn. You know, it's something where we make no assumptions. We give all kinds of diagrams. This is early on in the learner's history here. Here's the diagram, the schematic diagram. Here's what it's going to look like when you hook up the wires. So we give all those different kinds of aids, but we take the student through a series of skill performances to learn how to hook up the 3 kinds of applications here. I'm going to leave this, and I'm going to show you this is what we call our virtual simulator. Here, we're going to let the user, the learner, develop that same application. So if I go down this list, you're going to see the same instructions that were on the instructions for the hardware. And you'll see if I place the cursor over these devices, it shows me what it looks like. Here's a DC power supply. That's what's in this particular exercise. Here's a lamp. This is in this exercise. Any of you seen this demonstration before? You can raise your hand. No? Okay, good. You got a fresh audience. It's always fun. Okay, now there's been a tutorial that tells a student they can do all these things, and I've cut forward. And it says put the knife switch, but I put this push button switch. That's one of the things, by the way, in building these virtual trainers, we give the students some freedom. And one of the things we want them to do is make mistakes. That's good. You learn more from your mistakes than you do from your successes if you get it right the first time. So I'm going to build this circuit. It told me, which I did read to you, add leads. I can click on these terminals. You see the yellow circle there? That tells me that I'm ready to connect. So I'm not tightening anything with a screwdriver. All I have is a mouse here, but it makes it easy for me to build this circuit. And then it's going to tell me to do some things. One of the things we're going to do is we're going to set the power, and I'm going to turn it on. Notice, by the way, this does not look like the trainer you saw a second ago. But in this particular instance, it really doesn't matter. You don't need to have this trainer to do this kind of training. In fact, we picked these specifically because a lot of schools and a lot of companies have power supplies, lamps, switches, and wire around for students to work with. So now they built the switch and circuit, and you can see the light goes on. Now, how many of you have taught students before? Ivy Tech can actually go up at least. Okay. Typically, this is what your student is going to do, right? It's a power supply, and I can actually run this all the way up to 40 volts because that's what a student's going to do. Let's max this thing out. Okay. Okay. What happened? Okay. Well, if I did this on the trainer, I applied 40 volts to this bulb. Now, I wasn't paying very close attention, I'm sure you weren't either, but it's a 24-volt bulb. Now, how do I know? Well, one way I can know is if I clicked on that and I held it down, it went away. It'll tell me I applied too much power. But I can get my hand on this. See, I can replace bulb. Okay. By the way, I could even make it a 40-volt bulb if I wanted to. But I'll just leave it there for now. Another thing I could do is when we go further on and get into circuit analysis, one of the things we're going to be able to do is put in a multimeter. Now you notice I'm trying to click here, but I can't click on it. It's making me turn off the power before I add another component. So now we're getting into best practices, safety procedures. That's exactly right. So I'm going to put out, where is it here? My voltometer. digital multimeter. We'll come into the 20th century. So what I can do now, I can hook up my leads. I can build what I call a salesman's circuit test, because electricians would know better. And I'm going to set my, so it works just like the regular meter is going to work. When I turn this on, you'll see I got 20 volts over here. If I push the button, the light still goes on. But notice, I've got 20 volts. Why do I not have voltage here? Well, that's because I hooked it up wrong. If I wanted to see what my resistance, okay? Now, electricians know this, but we're going to teach you at another point when you get into circuit analysis and working with these instruments that you're not supposed to put volts through the system when you're looking for amps. It's going to cause damage. Here we just blew the fuse, except we didn't ruin anything. It's just like a bulb, nothing is wasted. This is what we call our virtual trainer. This is not designed to get people away from hands-on and into a virtual world. I always like to use the analogy, I don't want to get in a plane where the pilot has only flown a simulator. Not me. And I think it's the same with anybody in these maintenance positions. You want to be sure they get the hands-on. But what this does do, it gives the learner the opportunity to build these circuits, to understand what is going on, to get the content, and get actually a little skill practice before they get into the lab. This is another way that the learner gets to maximize their lab time. Now that's in a very basic area. I'm going to take a chance now and see if I can load up one that's a little more advanced.
While you're doing that, I will say that, again, we've probably had close to 300 industrial maintenance people go through training with us. You know, there was a great amount of trepidation, I guess, with respect to this online, the computer. That's not how most of these folks would have learned in the past. It's very user-friendly. It's easy to navigate. Within a couple of hours, they know how to do everything they really need to do to navigate the software. And actually, they're walking out with much better computer skills than what they would have had if they had never got onto that computer. And everything's going to computers, so it's a win-win there.
All right, we moved into a little more sophisticated area now. This is a motor control. It's a reversing control circuit. And one of the things we want to do is teach troubleshooting skills. So we actually have another simulation here where we have an application and the system randomly sets this up. I don't know what kind of fault I'm going to get here. Are there any electricians in the room? Electrical people? Nobody? Okay, well, we'll have fun then. We don't have somebody telling us we're wrong. Notice I turn on the system. I got my disconnect here. And this is an application. It's been powered now. And the application would have been described. I skipped forward. But if I push this button, the motor is supposed to go in a forward direction. Hey, it did pretty good. If I push this button, it's supposed to stop. I'm already getting an idea of what's going on because it's not stopping. And if I push reverse, oh, it goes in reverse. And it goes forward, but it's not stopping. Okay, so now I have an opportunity to figure out what's wrong with this circuit. Now keep in mind, if I'd gone through the system, I would have some ideas because I would have done the content. But I'm going to think, because the stop button isn't working, I might have a problem here. So what I can do is I can take my meter, put it over here, put it over here on the ground. Let's see. All right, I've got voltage coming to the switch. And I just click and drag in here. All right, let me see if I get. I've got voltage here now. All right, now it's. But I've still got voltage. Okay, so that tells me I'm going to guess there's something wrong with this switch. This switch is shorted. There might be something else, but you know, for me, close enough. All right, so now I click select fault, and I'm going to say that this switch is shorted. And put that in. I got it right. Okay, beginner's luck. So the point I'm getting at here is we can take a learner through a series of faults that they don't know are coming. Now, they've gone through a series of doing the learning here ahead of time. But the point is, this is one of the kind of simulations that we have in our more advanced systems.